let's take a quick look at some of the other hyperparameters on here. So let's start with criterion. Like these are two different scoring for the optimizers, meaning like, hey, they've got to have some way to compare. How do you know which split is better? You got to score it. So Gini and entropy to do with probability, and these are two different options. My personal experience is that it doesn't really make that much of a difference, but you can certainly try both of them to see. I mean, it's interesting. We're thinking about too, like what it's doing. It's different way to try to find the best parameters. Okay, so splitter, best and random. Again, default best. You could try some randomness here. Only two options. Okay. Min sample split, we covered max depth. Min sample split is actually a lot like min sample's leaf. I think my description of min sample's leaf was actually closer to what min sample split really is. You can see it says minimum number of samples required to split an internal node, whereas min sample's leaf says the minimum number of samples required to be at a leaf node. So, I mean, these are pretty similar. One versus the other may give like something slightly better, and both in conjunction, maybe you could get something slightly different there. Let's keep going. Min weight fraction leaf. The minimum weighted fraction of the sum total of weights. So weights are like the multipliers here. Of all the inputs required to be at a leaf node. Samples of equal weight when sample weight is not provided. Very confusing. Okay. Now, just because it's confusing doesn't mean you can't utilize it. Here's why. You can see that it says float. Okay, it's a float, so it's a decimal, and it gives you a default of 0.0. So clearly, you know, when you can increase that, right? And it's looking at the weighted fraction of the sum total of weights required to be at a leaf node. Okay, so it's saying that we're going to have some additional requirements potentially here. So we could certainly try that. Now, max features we just looked at. There's some random state, by the way. It's for any model. You can always do a random state, and that way, again, we can match scores. It doesn't really like change the model itself. Max leaf nodes. You can see a lot of these are about, you know, controlling like the stopping. Min impurity decrease. A node will be split if the split induces a decrease, you know. So there's a lot of like weighty stuff here. And I think sometimes what can be, we're not going to go into the details of all of these. Something that can be a little instructive is the ranges. Okay. Because if you have a general idea of what they do, and then you know what the ranges are, that's going to help you more. Some of these will carry over to XGBoost and some won't. And so you will get a lot more throughout this whole class. We're going to be doing hyperparameter fine tuning. So just because I don't cover in depth now doesn't mean we won't later. But there's certainly like so many, one can't cover them all in depth in a reasonable amount of time for every single like machine learning algorithm. Okay, so what I want to show you is like a range. So here's a range I used in the book. So if I go to the XGBoost GitHub page, and what you will find on these, so we can stick in chapter 2, are the Ipython notebooks. These are just like Colab notebooks. They are Jupyter notebooks originally. And when I click on that, you'll see that this is basically the code for the book of chapter 2. And I want to scroll down and show you this right here. So here is a reasonable range that you can check of different, so it's like a potential starting place. Now, you can see it's a lot, and I can also tell you that based on what I told you before, you can be certain that this would take way too long, like using a grid search. And note that it says something else. It says randomized search. Okay, so we'll come back to that. But the first thing I want to do is I just want to copy down the parameters. Okay, so I'm going to copy that in and put it in here. See how well it copies. Not bad. You know, it's always like annoying when it doesn't line up like the way you want it to, but whatever. Okay, I'm not going to use all these because it's way too much. But when you have like starting, Python doesn't like, if it's a comma after a dictionary, they should ignore the spacing, so we should be okay. When you have a good starting range, like you can just run it and use kind of like numbers. You can like totally do it without really even knowing what they mean. And that's not what I'm encouraging, okay? I'm stating it though because it's just the ranges are kind of the most important thing. Having reasonable ranges. And this is just there's not like an appropriate starting range. Well, how should I put it? There are inappropriate starting ranges, but it's not like that this is the ideal one. It's simply that, hey, here's one I've used before. Like it's reasonable, okay? And you know, I'm sure you can find different ones and even better ones, right? So like it looks like min weight fraction leaf. You know, this is also designed based on the number of rows. That could be a little small. So let's just try one of these by itself. Look, I have min weight fraction leaf twice on here. Okay, sometimes that's kind of fun to find a little mistake in the code. So you just delete that one. So let's just try. Let's see if like anything happens when we change it. So let's just go on that for the next one. Say, hey, maybe I don't really sure what it means, but it doesn't mean we can't use it. That's what I'm trying to emphasize here. All right, so I'm leaving that there. And what I want to do is do a new code cell. And did I copy it? I did. Say params equals dictionary. And then put it in there. Okay, I think I did something wrong here. Trying to copy too much. All right, so just there, I've just got like a min weight fraction leaf, and we're going to see if in fact we improve the score. Well, based on nothing else, we did get a 0.05. I don't know why I have those as so small. It must be from like a really large data set, you know. And this is also where, again, having some knowledge is helpful because, well, even if you don't, you can say, okay, well, if that's the best one, why don't I start there? And maybe, you know, I say change it and try like 0.1, 0.2, 0.3. Let's try that and see what happens. Get something better. And 0.05 is still the best. Okay, and again, I don't want to go off the deep end with like trying min weight fraction leaf. I'm simply indicating how you can use a range to try to help you. And now let's actually try it in conjunction with what we've had before and see if it makes any difference. So instead of min samples leaf, we're going to try min weight fraction leaf. I'm just going to get rid of this. Kind of overlapping code here. My apologies. So min weight fraction leaf. And let's try, so we got the best of 0.05. So let's go a little under 0.025, 0.05, and let's use 0.075. Okay, nice little tight range. And then, oh, I left out, oh man. So I want to be sure that I'm continuing like my best changes. Min samples leaf worked well for us. So I don't want max features here. I actually want min samples leaf. So I got rid of the wrong one. Too much copying and pasting, that's for sure. But hey, if you have a good little grid there, copy it over. All right, so let's see if this shows any improvement. Not necessarily expecting that it will, but you never know. Yeah, it's like the same score. Do you see these two scores? Like how we get it's like almost the exact same. And what's interesting to check is that it got it with the 0.05 and didn't make a difference, right? You're like, oh, why didn't it make a difference? Well, look, it's when you're minimizing the requirements for a leaf, we did that also with min samples leaf. So, if you do too many hyperparameters, they're doing kind of the same thing. You're not necessarily going to find gains by using them all. Okay. So that's min weight fraction leaf, but I'm showing you some of the ones I think are the most important, and we do have this big potential search here, right? So is there a way we can just do all that? Yes, we can use what's called Randomized Search CV. Okay, what Randomized Search CV does is it picks random combinations of these. And it's really fun. And one of the reasons why is because you may find like a better combination. Okay. By the way, this auto, I realized, I think it should, I'm going to put it as none. Okay. And again, these could be based on a different data set, but whatever, like it's just a starting place. Like note 2, I say that, but like you do want to kind of use what you have. I mean, look, with min samples split, is that what we were doing? Min samples leaf. Oh, looks like you can do that one by percentage also, right? So I'm putting in just a big grid, right? And it's one I've used before, so it's from this text. Look, looking back at it now, I feel like it could definitely use some work to be improved. But and we can adjust it in a minute, but it's just going to it's really cool that it looks for random combinations to find the best one. That's what I like. I think 3 should be in here because we got a good result from 3. Yeah. Anyway, let's just try this and see what happens. It's good to be consistent on your spacing, by the way. All right, so we don't have it in place right now to do the randomized search CV. So let's just do that right now. What we're going to do, if you go up to your grid search function, we're going to modify it. Okay. So we're also going to import randomized search CV. And we've got to decide if we're going to use it. So I like to set a parameter here called random, and it's equal to false. Okay. So what we do is this is the grid but it's actually not otherwise. So if we just say like, hey, if random, okay, then the grid equals randomized search CV. Okay. And everything else will be the same. There is one kind of cool thing. So if we want to include everything else, but it's how many searches it does. And by default, it's going to do, excuse me, it's going to do like 10, and we can up it, especially for a small data set. So, and sometimes like, hey, I forget, like what is it? Is it in? What is it? Well, hey, just, you can search it inside of like the scikit-learn. Like if I type in randomized search CV here, let's see what we get. We do get like it's, right here. And you can see, yeah, in iter, so number of iterations. So basically, by default, it searches 10 random combinations. We can up it for our data set. So what we can do, we go back here, and we put an in iter equals what? Well, it's a number that we're going to set in the function. So I'm going to just call it in. Sometimes I would call it in iter again. That's kind of what I usually do. I think that confuses some people, though, so I'll just call it in. Maybe be more clear. Number of random checks. A number of combos. Okay, so what I do is then I go up here and then I set the number of combos to say like 20, and I can change it to try to find different combinations. Okay, so just to recap, what did I do here? I gave us a new option where we can set random equal to true, and we can set the number of random combinations we're going to check, which we'll just do 20 for a default. And then it should show up in the model that if random is true, it's going to overwrite the default model here to the random combination CV, but because we call it the same thing, it'll still then fit it the same way like on the data. Okay, so you got to press Shift Enter to get the model or the function to update. And so now I should be able to use this big old chunk here. All right. So what my function is grid search. Got my params. That's how we do it, right? Yeah. But now, so you see where the random is in place? So I want to set random equal to true, otherwise it's going to take forever. And I'll go ahead and put the number of combos up here because we might want to change it. We might want to up it. So basically, it's just going to give us random combinations. But what's cool about doing this, I can tell you this. You can do like a lot of grid searches. Sometimes randomized search will give you new potential starting points. And that's its real advantage. Will it here? Who knows? Okay, it came back with something quick. Let's see, what's the score? Solid. 80, close to 81. That's close to our best score. And what's interesting looking at is like, well, okay, what are the, what changed? And you can see we got a good score with a smaller number of max features. Max depth was comparable to what we've had. Some of these we didn't even use. Now, like max leaf nodes, so min sample split 3, this is potentially a new starting place, okay? And furthermore, you can I want to do something different. So if you do it different, you might get something totally different, by the way. I'm going to copy everything, okay? Put it down here. And then what do we get? The splitter best, no surprise there. Let's not even use random. And so this is going to limit down the number of options. And let's just use entropy. This also helps us cut down. And let's limit some of these. So, you know what? Before I limit them, let's just try it again now. Let's try with 30. Okay, because that was really fast. All right. Run it again. Still really fast. What do we get? Look at that. Moving up, 82. And you can see we got some interesting little percentages here. Some of these are so small, it's interesting that do they make a difference or not? And let's just try one more. Let's just try 40. All right, it's so fast. I mean, you can do 50, you can do 100, right? It depends on the size of your data set. This is way more than 100 combinations. Let's just do 50. And you see that it took just a little bit of time. And it didn't, see, that's the thing, it didn't improve. It's not the case that you're going to improve it, okay? So I'm going to pause here and let you know what I would do going forward. I would do the following. I would use this as a potential starting place. I would look up some of these terms to get a better feel for what they do. And I would use some grid searches to change these ranges one at a time, okay?